Okay, let's go. You're live. No, that's super cool. Hello, guys. Good to see you. I mean, everybody's watching, so that's kind of schizophrenic. Whatever. What I've done today is I've made this interesting stack trace analyzer. Now, the problem that I encounter is that I code in Zed. Now, if you've never used Zed, it's like this new kind of experimental editor. I encourage you to try it out. It's really, really cool, in my opinion, and it's much more than Visual Studio. That feels like a cockpit of a Boeing 737 about to hit a World Trade Center. Um, Now, this is a really cool IDE because um, it's really fast, it's really responsive. It's, from what I see, it's pretty unloaded. I really like it. The main drawback is that it doesn't have a debugger. Not yet, at least, because it's still in development. It doesn't have a debugger, which is a huge drawback to any serious coder, right? So what I've done is that I wanted to replicate at least a little bit the debugging experience they had on Visual Studio um, from Microsoft, right? So I implemented this stack trace logger that allows us to, well, log the stack trace. Um, how it works is that when we want a function, let's maybe look at the API of the stack trace analyzer. If it's initialized, that will initialize the basically C++ provides you with a really interesting library called structures. And this library allows you to, during the runtime, print out the stack. It's called basic stack trace. And this output here, by the way, it's not for Clang, it's for GCC or MSVC. For Clang, the output is absolutely horrendous. It doesn't tell you the name of the method, so it's pretty much useless. But I still really wanted to use that. So what I've done instead is that I've created this macro here that takes in source location, current function name. So it takes the current function name and it maps this current function name to basically a code location, to basically a binary location that the structure is current returns. It's really, really cool. And I have this mapping here, this basic analog map here, simple analog map. We are basically parsing this input here, and then we are getting the ID. ID is just the location in the binary of the function was called right now. And then, okay, here we are getting it, and then we are just inserting this. And I could probably optimize it and do something like if location method mapping contains ID return. Yeah, it's probably better now. And maybe that's how it should be called. Yeah. And then you can simply call print out, which is also a static function, that will print out this stuff. Static is offset by 2 because the zero function in the call stack will be the stack trace current function, and the first function in the call stack will be printed out, right? So instead, what we are doing is that we are setting the second third item in the collection, right? And we are just printing it out. And if we don't have some function in our map, we'll just print out an unrecognized method. Now, there's a lot of unrecognized methods because that's because we are dealing with standard library, right? So there is moves, there is copies, there is compressions, there is conversions, there's everything there. Yeah. Hello, man. Good to see you. Sorry, sorry, just on a different window. So, what was I think? Oh, yeah. So, we have really nice printed. Yeah, I'm working on a stack trace analyzer. Since I'm using this ID, this ID is called Zed. It's an experimental ID, and it does not have a debugger. And it's a huge drawback, right? So I've written my own stack trace analyzer based on the source location and stack trace libraries from the standard library C++. And actually, I can present it right now how it looks. Mm, In order to trace a function, you need to call this macro inside it. So that's kind of the other method. What do you mean unclear? Let me hear it. Wait a second. Oh yeah, actually, good catch. Thank you. Wait a second. What about now? Is it better? Yo, is it better? Well, I'll stream, we'll see. So as I was saying, this is a stack trace analyzer. It analyzes the stack of the call stack of the function. So we build it. Now we'll run it. And let me run the client too. Wait a second. So C client. Okay, let's run it. Let's run the client, the under monitor here. And then, okay, let's run the client. And as you can see, there are stack traces here. So we can see that currently, I don't remember which method we are printing out. We are printing the copy constructor of connection structure. And as we can see, there are some out of unrecognized methods. Those are methods such as copy constructor, such as like moves, conversions, some implicit constructors, something like that. And unfortunately, you can't track them all, so it's kind of handicapped at this moment. But yeah, it works. What I'm actually worried about right now is that when you look at the logs, we are destroying the message handler three times here, and we are creating it only once, because I presume that we are copying it somehow, which I would like to, well, track right now, see what's going on here. So, yeah, we'll go to the server.h. Yeah, it's getting pretty dense. So what I think is going on is that we are copying it a lot of times. I wonder what will happen. Well, I'll be polite in the beginning. Message handler. Other. Right. I'll be polite. And I won't be deleting the move constructor, which probably should be done. It should probably be done. Okay, so we have this. Oh, good night, man. Thank you for the kind words, man. It really means a lot. I have really a lot of friends that I can share this with because, oh, that's life, I guess. That's so weird. And it's just so weird. I understand this. You've created the implicit the explicit copy constructor here, and the message is dropped. I don't understand what happened. I'm terrified. I hate it when something happens in code and I just don't understand why this happens. It's like the worst case scenario, I think. Like, I don't think there's a worst case scenario than just something happens and you don't understand why this happened. Like, even if it's a good thing, it's always like the worst. Something happened and you don't understand why. It means that, I mean, this is the worst. Like, how to cope with that? Get good, I guess, right? This is the correct solution here. Just get good. And so it's interesting, right? Because when you define a copy, this thing just stops being. Honestly, I don't know. It's honestly magical. Mm, push connection. Um, okay, so we are copying this thing this many times, and then the message handler is destroyed one last time. So that's really interesting, right? So that we are destroying it like this many times. So I believe what is actually interesting here that we shouldn't probably um, we should not discuss this as a connection because we are destroying it so many times. Instead, I believe we should probably discuss this as just a pair because um, I kind of want to layer this. And if we have connection here, I just don't like this idea that we have connection here. I think that the connections should start here. Like we are pushing this in for the first time as a connection here. We might even be creating connection here and just pushing it first time as a connection. Mm, but I don't. So maybe that's a difficult decision here. Uh, I really don't think we should be pushing it as a we should be using it as a connection in this code. That doesn't seem logical to me. I mean, it will look fun, but I believe that's the correct option here. And those are kind of trivial, I think. Like, I don't want to be calling them now. I really want to focus solely on this like tool. Um, and then we'll like really think about what happens next. Uh, now And well, it's funny that I do it this way, but I think it's just necessary. Um, it's kind of funny, but um, yeah, after some deliberation, I think this is the correct way to do this. It's not a comfortable way. I hate that I have to do it this way, but like maybe that's just the correct way here. Let me please get it together here. Thanks. Okay, so now that we know that the connection is established, when new connection established, what is extract? First time seeing this function. Wait, what's going on? Okay. Okay, now we can go back here and we can where is the printout? We can once again start printing out the connection and destroy it. Okay, so we are destroying it twice. Good news, we are destroying it twice, which is closer to home. We are destroying it once when we are pushing it. Okay, so there is a temporary created, and then there is after the temporary is created, we are That's such a cool thing that I've made. Holy shit, I'm so happy that I've made this thing. This is so cool. This is like the coolest thing I've made today. I spent whole day coding this project today, and this is like the coolest thing I've made. This will be a video. A custom stack tracer, man. That is something. It is retarded as hell, man. Like, look at this. You don't know anything, but honestly, we know that there's a temporary created, right? And which is something, I guess. And then we know that there's a wait pop. If we call wait pop, there's also a destructor created at the end of the wait pop function, right? Oh my god, I'm so happy that I made this thing. This is so cool. This is probably the coolest thing I've made today. Wow, this is like actually a piece of art. Or maybe not a piece of art, but this is a piece of software, man. Like, holy. So yeah, this is pushing, and I'm pretty sure that this is the push. This is the push. Hmm. I guess that if we also print out the trace here, print out. Wait, how's common utility stack analyzer print. This is so cool, man. This is the coolest thing I've done today. The stack analyzer. Holy, so cool, man. So cool. Hello to the lost soul that has joined the chat. I mean, joined the stream. I hope I'm doing something extremely cool, which is a custom stack tracer. I've built a custom stack tracer for this app because Zed has no debugger, so I'm the custom stack tracer, and currently I'm in pure joy because it works so well. Bang. Oh man, look at this. So cool. Well, it doesn't work this cool, I guess. Because it wasn't a copy, it was a move. Okay, yeah, it's true. So it creates, so it immediately moves it. That is so amazing, man. But okay, let's see what happens here. Okay, so we are calling a push. That is perfect, man. That is perfect. That is so good. I'm doing my own stack tracer. That is the best piece of software I've written this year, probably. Okay, so we are pushing it, and then yeah, and then from on connection established, and then on connection established from this function we call server connection to delete this. That is correct. And then we are popping it, but we are popping it from a different thread actually. So it would be cool. It would be cool if we could like assign which thread prints this out. So it would be also pretty cool. Stack trace. Yeah, this I guess would be really cool. Let's add it. And then what happens next is that the matchmaker um, grabs it immediately here in assemble in while here it grabs it immediately because it was waiting for it. So it moves it out of the lobby. It moves out the collection out of lobby and it moves it instantaneously into his own collection. So the connection in the lobby needs to be destroyed. And oh my god, I understand this code works exactly how I wanted it to work. Perfection. I mean, probably not perfection, but it is pretty damn good. This is going to be a fire video, man. Like I built my custom stack tracer. Maybe I'll make it in a tutorial actually. Like maybe I will just go over the code. How did I make it? It's so cool. Um, yeah, so this works as intended. this works 100% as intended. Let me think for a second. So we have this. This works. Yeah, I don't think. Yeah, I mean this works intended. We are not destroying it a lot of times. It's good. We are creating it. We are pushing it. Yeah, I mean this is absolutely. I'm aware that this is probably the most effective way to do this. I mean, we have to mark every function that we want to, each function that we want to identify. Normally, this would be supported probably better by the compiler, but in my case, I needed to build it myself, and I've done it because things like blocking compilers ain't gonna stop me. For the first time in a long time today, this is the first time in a long time that I feel pretty good at coding. It will probably be shattered in a second, but today, right now, I feel pretty good. Pretty good. Where's the print out function? Yeah. Okay, so let's compile it. And let's watch one last time how the destructor behaves and where it behaves. And we will probably continue afterwards. I'll show you what I've done because today I've built a lot of things actually that I'm pretty proud of. So yeah, so it's destroyed basically 2 times, and this is perfect. That's exactly how many times I want to destroy it. Now we'll join. 2 new players will join now, so that we can see what happens. One player joins um, and join. Yeah, it's joined, and the same 2 destructors were called. It's okay, and then the next player will join, and it's the game has been started, by the way. Now the game has concluded. That's after the game has concluded, the players return to the lobby. However, I want to make sure of something. Okay, so the game is started. After the game has started, as you can see, we're going 1, 2, 3 times, which I guess this is quite interesting. Well, I understand those 2 calls here. It's wait. Okay, those are wait pops. Because I understand those 2 calls. Those are calls from the matchmaker, and this call this should be later, I think. But I guess this is some um, concurrent bullshit. Um, Now, what's going on here? We are removing 4 connections, and this is confusing to me because um, this is quite confusing to me actually. Why we are removing 4 connections? This is okay. So this is irrelevant because this is again a wait pop, right? So this is one. There's too many wait pops. I feel. Um, oh, because we started 2 games. Never mind. We have started 2 games, and that's why. Okay, so we have started 2 games, so those wait pops are from a different session. But here, I want to zoom in on that thing. Okay, so that's correct. That is correct because again, this is a correct logic. How it works is that we have the matchmaker, and the matchmaker basically matchmaker and the match conductor. Let's focus on those 2. The matchmaker it assembles the lobby. So when it assembles the game. So when we have 3 players in the lobby, I mean, every time there's a new player coming into the lobby, it grabs this player for himself. And when he has when this matchmaker has 3 players in his intermediate buffer is a typically allocated array. When 3 players are already in the intermediate buffer is moved to the match conductor. So there won't be any destructor called here, keep in mind, because we are moving only the data, and this is pre-allocated, so nothing is destroyed. The allocation, the data is still, I mean, the array is still there, so objects are still there. They just have invalid data because the data is moved to the match conductor, and then the match conductor, when it's called with the when this function is called, as you can see, this is a make unique, and when this function is called conduct game, what happens is that this is some placeholder logic for now, obviously. But after the end of the game, what does the match conductor do is that it returns players to the lobby. So again, he pushes them out, but removes them out to the lobby. So we can see that those four, there are 3 destructors of connection code for each player that has been in this in the players array of match conductor, which is absolutely amazing. So there is again 4 free moves, 3 destructors, and then again we will have 3 free. Oh yeah, we are. Wait, oh, well, it's kind of hard to parse for this because it's concurrent code, right? But generally speaking, it's correct. This is a correct logic. Um, it's really cool. I think this is tremendous. So this way we know that everything is going on fine under the hood in our code, and you might be surprised, like why you are going so much depth. Why you want to know like every little destructor when it's being called. Well, I want to know when every destructor is being called because if I don't know it, like I really call myself a programmer if I don't know how my code works. Like I think that's just the bare minimum that you should do. Just thoroughly understand like what my code does actually. And that's the exact behavior I wanted from my code. Which is pretty fucking cool, I think. I'm so happy that it works. Really, I'm really happy that it works. Status. Yeah, for now we can. I guess for now we can remove the design directory. I don't know if I will ever do anything in the design directory. Probably, maybe yes, maybe no. Nobody really knows right now. I want to make a UML design for that, but I don't think it will happen. So we have a couple of files that have been modified and a couple of files that have been added. Yeah. We need to analyze those files. Okay, so maybe I will just kind of comment this. Since I am creating this project using Zed Editor, I have limited access to debugger. I could port this project to Visual Studio. However, that would be not as ambitious as creating my own stack analyzer. Stack analyzer. This class implements a stack analyzer. This class implements a stack analyzer. A call stack analyzer. Function. How it works. Each method that we want that developer wants to recognize on runtime should be added to should call macro in the beginning. Init. This macro will place name of the function macro in the beginning. Do not use map row. It will hello. Hello to the person that has joined the stream. I hope you're doing well. Two new subscribers. That's just purely awesome. Love it. Let's update the counter then. Hello, how are you, man? 07. Yeah, I didn't watch football in a long time, man. Cristiano Ronaldo is like your favorite player? Yeah. Today I've done this very interesting stack analyzer. I can show it to you. It's really cool. So, my problem is that I'm using Zed. Zed Editor has no debugger, so I wanted to create a stack analyzer for myself. Mm. In my country, it's 7 p.m. 7 p.m. 7 p.m. in 5 minutes, right? So yeah, this is stack analyzer. It analyzes the call stack of the function. You can basically map the function with trace current function, and this function is added to like internal mapping here. What happens next is that you can call this where is it? Print out function to print out the whole call stack. Some of the functions will be recognized, and we can print out their name, and some of the functions will not be recognized because they're, for example, like library functions that cannot be modified by me. So this is how it works. Take a look. We're running a server here, and then we're running a client. And it will connect, and bang, you have a whole stack trace here. Look at this, man. That's absolutely terrific, isn't it? Look at this, man. We can see that there is some message handler operator that then calls on new connection established, and then calls this destructor. That's absolutely so cool. Because currently I'm tracking the destructor of this thing called connection, right? So if you take a look at the server here, in the connection here, we are tracing it and we are printing out the call stack, right? So this is really powerful in general. It's really powerful and really cool. I have it. I've coded it myself today. No ChatGPT was used whatsoever to code this up. The only thing I needed help with was this macro because I've never written macros, so I didn't know how to properly format it. But yeah, that's such a cool thing, right? Because you can track how functions are called, especially because it's a multi-threaded application, right? This call stack tracer. It's totally thread safe, and you can call it from a different multiple threads because it's also static. So it's a really powerful class. I mean, I'm kind of proud of it. I have not coded anything like that before, and I'm really happy that I've done it right now. And I'll be ending stream soon actually because I'm coding since like beginning of the day. Um, so I'll be ending stream and ending just coding for today. But I'm so happy I've done it. I mean, I'm sure that if you ever coded, you probably had those moments like, damn, I'm pretty good. And then you like read code easy and you're not good enough. um, as you can see, I've done some changes. Mm. Let's see how many actual changes those are. Let's see. Stack trace analyzer, match maker, and match conductor. Yeah. 435 insertions, 240 deletions. That's a lot. Yeah, I mean, today's coding session was absolutely epic, man. Like, holy shit, I was coding whole day. I feel so good. Like, I feel that I finally done something. Holy crap. It's commented well, so people that read this code actually know what's going on. Yeah, so I can show you one more thing that's also pretty cool. Well, as I said, we can compile this out. We'll compile this out so we're not bothered by it. I can show one more thing though, like that I also managed to do today. Yeah, bro. Like, I mean, I don't know if you've seen that, Oh wait, what's going on? What's going on? Oh yeah, one of the apps was still running in the background. I'll show you something. We can. What I've done today is that I've created the server, right? And now what happens when three players join? Okay, so three players join. Those three players are grabbed and they're put into one game. And right now, there's obviously a placeholder logic here. Here is a match conductor. It's responsible for that. Now, this is a placeholder logic, as you can see. You basically wait 10 seconds, and then the game is finished. Right? So let's do this. Let's create a server here. Let's create a client. And now, also, let's create another client. And let's create another client. And now, as you can see, creating WebSocket. Welcome to the game player 2. Welcome to game player 1. Wait. Let's wait a little bit, right? The game has finished, and then the new game has started, because when the game is finished, all of the three players, they return to the lobby. When they return to the lobby, the matchmaker can grab them from the lobby and then pass them to the match conductor to create another game. That's how it works. And as you can see, it works flawlessly. There's no race conditions whatsoever, I think. So yeah, this is a working application so far. What is not working, unfortunately, is stopping the game. I can stop it, by Control C, but this is quite brutal. So the next thing I'm going to I'm going to work on will be actual stopping of the game and like swift resolution of errors. And then I will do the whole poker logic and communication, like more advanced communication from the client, from and to the client. So this starts to take shape, and I'm super proud of it because this will be a really good pet project. I think, like networking, multi-threading, modern C++, like this stack trace analyzer. Also, like this is a really good pet project already. So I'm really happy that I'm actually like got my shit together and I made it, because this is super cool. Okay, as I said, thank you for watching me. Thank you for coming to my stream, subscribing to my channel. Thank you for the wishes. Like, it's really awesome. I will cut it. I will cut it for today, and yeah, I will just go and probably eat something, and rest. So yeah, thank you very much to everybody who's joined today and followed me. Subscribe to my channel. Follow me on Instagram. Actually, I will start doing my Instagram link probably. And yeah, see you probably tomorrow. I mean, like, I will stream tomorrow probably too. Like, I'm streaming every day right now. I'm a streamer, bro. But, oh man, being a streamer is the last thing I want to be. However, right now it's good for the exposure, I think, and good for the practice, because I'm actually practicing coding. Yeah. So goodbye, everybody, and see.